Hi everyone, today we're diving into a really cool math puzzle called the Collatz Conjecture. I'll break it down in simple everyday terms and show you some surprising patterns that emerge. Back in 1937, mathematician Lothar Collatz came up with this interesting idea. Here's how it works. If you start with any positive number and it's even, just divide it by 2. If it's odd, multiply it by 3 and add 1. No matter what number you choose, if you repeat these steps, it seems you always eventually end up at 1. For example, start with 5 and you get 5, 16, 8, 4, 2, 1. Pretty neat, right? Now, here's a fun twist I experimented with. Instead of multiplying an odd number by 3 and adding 1, I tried multiplying it by 3 and adding 3. Then, as before, I divided by 2. What I found was that numbers eventually fall into a loop. They bounce back and forth between 6 and 3. In this method, the sequence ultimately ends up at a number that is 3 times the power of 2. Here's a quick Python script that shows this process in action. This function runs until it detects a repeat. I've provided separate simple Python codes for each method, making it easy to compare the two. Imagine the sequence as a tree. Each number is like a branch. When you hit an odd number, applying our rule turns it into an even number. This is like a branch splitting off. Then, when you divide an even number by 2, it's like trimming that branch down. When we're examining the Collatz conjecture, a fascinating pattern emerges. Sequences tend to encounter more even numbers than odd ones. Ultimately, every sequence ends at 1. If multiplication happened more frequently than division, the number wouldn't decrease. Also, we can conclude that a sequence continuously alternating between odd and even numbers. Now, here comes the conclusion. No matter which variant we use, whether multiplying an odd number by 3n plus 1 or by 3n plus 3, the sequence eventually settles into a loop. Both the original rule, 3n plus 1, and my modified rule, 3n plus 3, tend to produce more even numbers than odd ones. With the standard rule, many sequences become a power of 2 and then settle into the familiar 4. 2, 1 loop. With the modified rule, it often ends up with numbers that are 3 times the power of 2, leading to the 12, 6, 3 loop. By understanding how these simple operations flip numbers from odd to even and back again, we start to see the natural patterns and loops in the sequence. This might be one of the keys to unlocking the mystery behind the Collatz conjecture. Thanks for joining me on this exploration.